This is a demonstration of an application I created called Virtual Z-chart. First, what is a Z-chart? A Z-chart is a technique used by field engineers as a backup to their depth system. It consists of recording the depth at each corner on the drum. In the event the depth system fails, you have a reference at each corner and you now can recover the wire line out of the hole with some accuracy. I started out with this application to predict mathematically in advance what these depths at each corner would be. Later, I realized that there's another advantage in the sense that you can use these same mathematical equations to predict very accurately what the length on the drum is in the event this cable length is unknown. Like all of my applications, all the yellow boxes require data input, and some of these I have pre-filled out. The drum size allows you to select from a number of default selections. Likewise, the cable size has a number of pre-built selections. In the event that your drum is slightly different, you can override the default value. And likewise, if your line is a little worn, you can override the default new value. This now brings us to entering the length of the cable on the reel. This can be attained from accurate cable records or electrical properties. And there's been a number of calculators posted that provides an estimate based on some measurements of the drum. This is what I have over here at the right, and you can see I've entered the data. Down here at the bottom, it shows that this drum has a total capacity of nearly 33,000 foot of cable. And given these parameters, we see that it's estimating about 20,443 feet. We will enter this estimate for the length of cable on the drum. You now see the Z-chart is populated with the estimated depth corners. The accuracy of this prediction is based on the accuracy of the drum measurements and the accuracy of the cable diameter. Of course, this won't ever be perfect, so here's how you overcome some slight inaccuracies. As you run in the hole, you stop at the first corner and enter it in the user data. Here we'll enter 125 feet. You now select Adjust Length to match first corner. You can see that all the predicted depths has changed. The real benefit of this application is in accurate estimation of the length of the cable. To obtain this, you must catch corners at each flange and enter them into user data. We'll pause the recording and enter these depths now. Okay, now that the user data has been entered, you can see there are some slight differences. In fact, we calculate this as a total delta of 687 over here underneath the drum picture. What the application will now do is run through an iterative technique, changing the estimated length of cable on the drum until this delta calculation is minimized. We'll start that by clicking on Estimate Length Based on Actual. You can see it began about 5,000 feet below the original data. This takes a few minutes, so I will pause the recording at this point. Very well, now that the iteration has finished, you can see that it has settled on a total length of cable on the drum of 20,920 feet. And it has minimized the difference between the calculation and the user value to 382. This concludes the virtual Z-chart demonstration.